This is the second video for section 2.4 on applications using trigonometry, and so I'm just going to work through a couple of problems that are a little bit more challenging. I wish I were a better artist, but you'll just have to bear with me. So here's what we have, a light pole, and then two people standing to the left of the light pole. We'll call this person person A and this one person B. Here's what we know. A is 30 feet away from the light pole, and when he looks up to the top of the light pole, his angle of elevation is 40 degrees. B, because he's farther away, when he looks up to the light pole, his angle of inclination is 35 degrees. Okay? And our question is, to solve for x, the question is, how far are A and B from each other? And it doesn't seem that we have enough information, but we really do. Okay, so we're going to start out and we're going to assume this light pole is perpendicular. And we're going to look only at the triangle, oh, let's not call that x, let's call it h, that is made by person A, the 30 feet and the 40-degree angle of inclination. And we're going to solve for h. All right, so we're going to say that the tangent of 40 equals h over 30. And we're going to find that h turns out to be 25.17, rounded to hundredths. Okay? Now we're going to go ahead and do a second tangent problem, and this time we're going to look at the big triangle, and we're going to use a 35-degree angle. We're going to call this entire distance, we need a new variable, let's call it y. And so we're going to say that the tangent of 35 is equal to that h we found, which was 25.17, all over y. Okay? So this time we're going to take the answer we got in our calculator, the 25.17, divide by tangent of 35, and what we get is 35.95. And I guess we're in feet. Have I said the units? I haven't. So if the entire distance is 35.95, and if from A to the light pole is 30, then that means that the distance from A to B is going to be just 5.95 units. Okay? How does that look? Does that make sense to you? Probably look at this a couple of times. We'll do a couple of these in class. The second application that I want to take you through involves a different way to measure angles. And so if any of you have any experience steering boats or flying airplanes, you will be familiar with this idea of bearing. And bearing is a way that boats and planes measure angles. All right, so our angles always start from the positive x-axis and go counterclockwise. When we're in bearing, we have a north-south that's kind of our base, and then we write the angles based on how far east or west the terminal side is from the north or south. Let me show you what I mean. So I'm going to go ahead and draw this. If I give you north 50 east, okay, that is a bearing measurement. It means that you are 50 degrees east of north. It's kind of goofy, you just have to get used to it. All right? If you ever become a pilot, you'll thank me later. So 50 degrees of north, the way we would draw that is we would start due north and then draw a ray so that this angle is 50 degrees. Okay? When we do bearing, oftentimes the triangles we draw are not back to the x-axis, but that's okay. Alright, so let's go ahead and do a problem with this. Let's say that a boat takes off and it motors for 238 miles, and let's go ahead and keep the north 50 east. Okay? And then the question is, when it stops, how far has the boat traveled north? And then how far has the boat traveled east? Okay. All right. So let's go ahead and draw the picture again. We said that 50 was 50 here, right? And then if I draw this triangle, then the question, how far north will be this side, and how far east will be the measure of that side. All right, so we've got 238, and let's just go ahead and give some arbitrary variables. When I'm solving for the north, A, from 50 that is the adjacent, so I'm going to say that the cosine of 50 is equal to A over 238. So that turns out to be 182.32 miles. And then to solve for B, now because B is opposite, the sine of 50 is B over 238. And that turns out to be 152.98 miles. And so I think what you'll see about the application problems is that the trig you use to solve it is not tricky, but understanding the diagram and where the angles are and setting up the problem is really the challenging part. Okay, thanks for listening. I will see you in class.